So in this section, we're going to cover interest. So interest can be seen as the cost for borrowing money. So if somebody gives you money, you need to pay interest on that principal taken out, or the return on investment. So if you invest money, the money is gaining value. That gaining value is the interest. So we've got a simple interest formula. Interest is P times R times T, where P, R, and T are defined here. P is the principal. That's either the initial amount borrowed if you're loaning money, or invested if you're saving money. R is the annual interest rate expressed as a decimal. And the time is the duration that the money is either loaned or invested, typically in years. So if we invest $2,000 at a simple interest rate of 4.5% for 2 years, let's find the principal, the interest rate, the time, and then we'll calculate the simple interest. So the principal is the $2,000 that we invested. The annual interest rate, well, we need to turn 4.5% to a decimal. We've done this for a few sections now. So we know we move the decimal place over twice to the left. So that's 0.045. It was 2 years' time. So then the simple interest follows this formula, P times R times T, which is 2,000 times our interest rate expressed as a decimal times the number of years. And now we'll use our calculator, 200 years. That's not right. That's just 2 years. So 2,000 times 0.045 times 2 years. And that's $180 that we would gain as interest on this investment. So in calculating simple interest, look for your principal, look for your rate, turn it into a decimal, and look for the time that the investment or loan is going for. So now we have an example. Calculate the interest owed if you take out a loan of $5,000 at 6% for 1.5 years. This is very similar to the above example. Please pause this video and try this on your own. Unpause to check your work. So our principal is $5,000. Our loan is 6% as a decimal is 0.06. Time is 1.5. So we take 5,000 times 0.06 times 1.5. And if you prefer, these are just showing the multiplication sign, the x's. It's not a variable, it's a multiplication sign. You could also just write this in parentheses, just based on your preference. They're the same expression. And that'll be $450 owed as interest on this loan. That's for a simple interest rate loan. So this is the simple interest rate because we're only taking out an annual interest calculation each year for the amount of the loan length. So let's go over the idea of future value. Future value is the principal plus interest. So looking at our previous example, you know when you repay the loan, it's not just the interest owed, but you also have to pay back the principal that was given to you. So when the loan is repaid, the interest is added to the original principal to find the total amount due. So for our previous example, the interest of $5,000 at 6% for 1.5 years was $450. So the total cost of the loan would be the principal plus the interest in our example. That's the amount due. The amount due at the end of the loan is the future value of the loan. The principal value now is the present value. So in order to calculate the future value, we would take the principal times 1 plus the interest rate expressed as a decimal times the time. So if we wanted to calculate the future value of a loan of $1,060 at 6.5% for 3 months, so if time here is in years, we've got to first change this 3 months to years. So 3 months out of 12 months will give us the total amount in years. So that's 0.25 years because we divide by how many months there are in a year. So the principal is 1,060. The rate 6.5. Move the decimal place over twice. 0.65 because it's a decimal. Time, we did have to change it to years, which is 0.25 years. So the future value is the principal times 1 plus the rate times the time. So that'll be 1060 for us times 1 plus 0.065 times 0.25. So 0.25. Now let's get our calculator. I'm first going to multiply these and add 1 to it. My calculator is relatively simple, so you have to do things in the certain order. So 0.65 times 0.25. Now add that to 1. And that's the value I'm multiplying by 1060. And we get the future value of the loan will be this amount. So that will be our future value of the loan. Now, future value can also apply to savings. So this example is extremely similar. Calculate the future value here based on these criteria. I encourage you to pause the video and attempt this on your own. Unpause to check your work. So our person saves $4.95 a day, 5 days a week for a year. Determine the future values if this savings is then invested at 5% for 2 years. So the total savings is $4.95 a day, 5 days a week. And how many weeks are there in a year? 52 weeks in a year. So this gives you the weekly savings. And then this times 52 gives you the year savings because there's 52 weeks in a year. So that's kind of how you think about those. So we multiply 4.95 times 5 times 52. And that gives us a total savings of $12.87. Now this is the amount that we want to invest. So that becomes our principal. Our interest rate was 5%, so 5% as a decimal becomes 0.05, and it was 2 years. So the future value from our formula above is principal times 1 plus r times t. So that's our principal of $112.87 times 1 plus the rate times the number of years. So let's calculate this in our calculator. And we should get a future value of $101,415.70. So now our next idea is present value. This comes from, suppose you know 10 years in the future I'm going to need $10,000. How much would I have to invest now in order at a certain interest rate over 10 years to become $10,000? So the formulas determine how much money needs to be invested now to achieve a specific future value, taking into account the interest rate and the time value. So the formula for present value, which is used by the acronym PV, is equal to the future value needed. This is what you need in the future, divided by 1 plus the interest rate you expect to get, with the exponent of the number of compounding periods and years. What I mean by compounding periods, so far in this example, this was a simple introduction to interest. We've only talked about annual interest rates, but interest could compound in many different time periods. It could compound daily, monthly, weekly, yearly. So if it compounds yearly, then N is 1, because it's the number of compounding periods in the year. If it compounds monthly, and here I just realized there's an error in the notes. Could we make this divided by N? So let me do this written out again. It should be 1 plus R over N raised to the N over T. So going back to what we were talking about, if it compounds monthly, well, that's 12 compounding periods in a year, so N would be 12. And if it compounds what's called semi-annually, that's twice a year, well, then there's 2 compounding periods in a year. So this is just a quick key guide of how you would figure out what the in value would be. It's the number of compounding periods in a year. So let's use this formula, and remember we did make this edit. The notes had an error. This should also be divided by in. So with that corrected formula, let's find the present value for this future amount. So how much should we invest at 3% interest to have $4,000 in 6 months? Now here it says simple interest. I want to draw your attention to that. When they say simple interest, this adjective means something mathematically. Simple interest is compounded annually. So if it's compounded annually, they're telling us n is 1. So watch out for that small detail. Simple interest is implied to be compounded annually. Now 6 months, our t is in years. So to turn 6 months, I have to turn it into years. So t is 6 months out of 12 months. So that's a t value of 0.5. Our rate was 3%, changed to a decimal is 0.3. Our time is 0.5. The future value we need is $4,000. So the present value will be the future value, $4,000, divided by 1 plus, okay, the rate of 0.03 divided by 1, because our n is 1, as we found here. And the exponent is 1 times 0.5. So in calculating exponents, you can calculate exponents. I might need to make my calculator have more options. I think I need this one to show. Okay. So this 1 plus 0.3 over 1, that becomes 1 plus 0.3, or sorry, 0.03. That's the inside of the parentheses becomes the 1.03. So let me rewrite this. Denominator. 1 times 0.5 is just 0.5. 4,000. So if I calculate the denominator here, my exponent button looks like this. In your calculator, you might see a little upside down V. That could be your exponent button. If you can't find your exponent button, send me a picture of your calculator and I'll try to identify it for you. So that's the denominator of my function, and I want to take the 4,000 and divide it by that. And we get, based on my calculation, 3,000. I'm going to round 3,941. And then to round to 2 decimal places, 317 comes after it, so we round up. About $3,941.32 should be invested now in order to, at 3% of simple interest, to have 4,000 in 6 months. So we would need approximately 3,941.32 now to have this much in 6 months. So that's all for this section. As always, if you have any questions, let me know, and I'll be happy to answer them. See you in the next section.